Welcome to our channel where today we will be exploring the one force that literally keeps us grounded, gravity. But before we take a deep dive into this invisible force, make sure to hit that like button so you won't miss any of our fascinating videos. Now let's see what secrets about gravity we can uncover together. Have you ever wondered why when you jump up, you always come back down? You might think it's because the ground is hard or maybe because there's air to slow you down. But actually it's something much more mysterious and powerful than that. It's gravity. And gravity is one of the fundamental forces of nature. It's what keeps us on the ground, what makes water flow downhill, and what keeps the planets in orbit around the sun. But despite how important it is, we still don't really understand how gravity works. You might think that you know how gravity works. After all, you experience it every day. But the truth is that scientists are still working to figure out exactly how gravity works. What we do know is that gravity is what gives mass its weight. If you have a mass, then you have a weight. And the more mass an object has, the stronger its gravitational pull. That's why the Earth, which has a lot of mass, has a strong gravitational pull. And that's what keeps us on the ground. But gravity isn't just a force that pulls things down. It's also what keeps things in orbit. For example, the Earth goes around the Sun because of gravity. The Sun's massive size creates a gravitational field that extends far beyond its surface. As the Earth approaches the Sun, it begins to fall towards it. But the Earth is moving so fast that it falls around the Sun in a continuous loop. The same thing happens with the Moon. It's actually falling around the Earth, but it's moving so fast that it stays in orbit. Have you ever wondered if there is anything that can escape the clutches of gravity? If not, here's an amazing fact for you. Light doesn't have any mass, so it's not affected by gravity. That's why light travels in straight lines. It's not pulled towards massive objects like stars and planets. This amazing property of light allows us to see things that are very far away. Since light from distant galaxies can travel to Earth without being affected by gravity, we can observe these galaxies and learn about the universe. In our everyday lives, we often take gravity for granted. After all, it's always been there for us and we don't usually think about it. But when we start to explore space, we quickly realize just how unique and special gravity is. For example, on other planets, the gravitational pull is different from what we're used to on Earth. On Mars, for example, the gravitational pull is only about 1/3 of what it is on Earth. That means if you could jump on Mars, you would be able to jump much higher than you can on Earth. Similarly, the gravitational pull on Jupiter is more than twice as strong as the Earth's gravitational pull. That means if you were on Jupiter, you would weigh more than you do on Earth. Here's another fun fact about gravity. When you're in space, you actually experience weightlessness. That's because you're in a constant state of free fall. Since there's no air resistance, you don't feel the effects of gravity. That's why astronauts appear to float around in space. They're not actually floating, though. They're in free fall. We all know that gravity is a force that pulls things towards the center of the Earth. But did you know that it also affects time? According to Einstein's theory of general relativity, gravity affects time in a very interesting way. Time passes slower near a massive object like the Earth compared to time in space. This means that if you were to travel to a planet with a stronger gravitational pull than the Earth, time would pass even slower for you than it does on Earth. Conversely, if you were to travel to a place with a weaker gravitational pull, time would pass faster for you. This phenomenon has been proven by experiments, and it's one of the amazing ways that gravity affects our everyday lives. Have you ever wondered why when you drop two different objects at the same time, they hit the ground at the same time? It seems obvious, right? But it's actually not. It has to do with the properties of matter and the force of gravity. First of all, we need to remember that objects have mass. And according to Newton's law of universal gravitation, all objects with mass attract each other with a force that is proportional to their masses. This means that the more massive an object is, the stronger its gravitational pull. Now, when you drop two different objects at the same time, they both experience the same gravitational pull due to the Earth's mass. This means that both objects accelerate at the same rate, regardless of their mass. This is why a feather and a bowling ball dropped in a vacuum would fall at the same rate. However, in reality, this doesn't happen because air resistance plays a significant role. Air resistance is a force that opposes the motion of an object through the air. And it depends on the shape, size, and speed of the object. That's why a feather falls much slower than a bowling ball because it experiences a much greater amount of air resistance. However, if you were to drop both objects in a vacuum where there is no air resistance, they would both fall at the same rate. Have you ever looked up at the sky and wondered why things fall down instead of up? Or have you ever jumped up and down and wondered why you don't keep going up? Well, it's all because of gravity. But what exactly is gravity and why does it pull things down? To answer this question, let's go back to the basics. Everything in the universe has a gravitational pull. The Earth, the Moon, your phone, even you. The strength of this pull depends on the mass of the object. The more massive an object is, the stronger its gravitational pull. So why does the Earth have such a strong gravitational pull? It's because it's huge, like really, really big. In fact, the Earth is so massive that its gravitational pull extends far beyond its surface. This means that everything near the Earth, including you, is constantly being pulled towards its center. And when something gets too close to the Earth, it falls. That's why when you jump up, you come back down. The Earth's gravitational pull is just too strong to overcome. But it's not just the Earth that has a gravitational pull. Everything in the universe does. That's why when you walk next to someone, you're actually being pulled towards them. It's just so tiny, you can't notice it. But if you were on a planet with a very strong gravitational pull, you would feel it much more. For example, if you were on a planet with a gravitational pull 10 times stronger than the Earth's gravitational pull, you would feel like you were being pulled towards the ground with a force 10 times stronger than the Earth's gravitational pull. It would be like trying to walk through honey. Do you ever wonder what holds our solar system together? What keeps the planets in their orbits around the sun? The answer is gravity. Gravity is an invisible force that pulls objects towards each other. It's what keeps us on the ground and what makes apples fall from trees. But it's also what keeps the planets in orbit around the sun. The sun is a massive ball of hot gas and it has a strong gravitational pull. This is what keeps the planets in orbit. If the sun didn't have a gravitational pull, the planets would just fly off into outer space. The Earth's gravitational pull is what keeps us on the ground and gives us our weight. But it's also what keeps our atmosphere in place. Without gravity, our atmosphere would just float away into outer space. This is why it's impossible to have a conversation on the moon. There's no atmosphere to carry sound waves. Gravity is also what causes tides on Earth. The moon's gravitational pull is what causes the tides to rise and fall. When you think of gravity, you probably think of a force that pulls things down. But did you know that it's actually a force that brings things together? It's what causes the tides, what keeps our atmosphere in place, and what keeps the planets in orbit around the sun. So the next time you take a step, remember that you're actually doing a lot more than you think. You're taking a step on a planet that's in orbit around a star, that's part of a galaxy that's flying through space. And you're doing all of this under the watchful eye of gravity. Thanks for joining us today as we explored the one force that keeps us grounded, gravity. Remember to hit that like button for more fascinating videos. Until next time, keep looking up.